Picture this: winds whipping through a kaleidoscope of clouds at over 300 miles per hour. A storm so colossal it could swallow Earth whole, and it's been raging nonstop for centuries. Or imagine auroras so vibrant, they'd put the northern lights to shame, glowing fiercely at the poles of a gas giant 11 times wider than our planet. This isn't science fiction. It's Jupiter. But here's the twist. Jupiter's weather is so bizarre that even the best scientists on Earth can't fully explain it. How does a storm last 350 years? Why do its poles glow with auroras that dwarf ours? And what secrets hide in the layers of its turbulent atmosphere? Stick around, because we're going to unravel these mysteries. And I guarantee you won't see Jupiter the same way again. Jupiter isn't just another planet, it's a cosmic masterpiece. The largest planet in our solar system, it's so massive that it doesn't even orbit the sun in the same way other planets do. Its immense gravity pulls it slightly off-center, making it a true celestial heavyweight. But what really steals the show is its weather. Unlike Earth, where weather depends on the oceans, the sun, and our atmosphere, Jupiter operates on an entirely different set of rules. There's no solid surface, just endless layers of gas and liquid that swirl and churn in ways that defy our understanding. And then there's the Great Red Spot. You've seen the pictures, a giant reddish storm spinning like a slow-motion hurricane. But did you know it's shrinking? Or that it could disappear altogether within our lifetime? That's just the beginning. From its hyperspeed winds to its dazzling polar auroras, Jupiter's atmosphere is the ultimate alien weather system. But how did it get this way? And what could it tell us about weather patterns on other planets, or even on Earth? Let's start with the big question: how does Jupiter's atmosphere even work? On Earth, weather is powered by the sun's energy, heating the surface and causing air to rise, cool, and fall in predictable patterns. But Jupiter is over 484 million miles from the sun. That's 5 times farther than Earth, and yet its storms are far more intense, its winds much faster. Where does all that energy come from? Scientists believe Jupiter generates its own heat, thanks to the incredible pressure at its core. But here's the catch. The deeper you go, the stranger it gets. The pressures and temperatures inside Jupiter are so extreme that hydrogen, yes, the same hydrogen we use in balloons, turns into a metallic liquid. How does this metallic hydrogen affect the planet's atmosphere? And what role does Jupiter's rapid rotation play? A day on Jupiter lasts less than 10 hours, spinning so fast it flattens the planet at its poles. That rotation creates jet streams that slice through its atmosphere, shaping the iconic bands of color we see from Earth. But this is just the beginning of the mystery. Let's dig into the Great Red Spot. This storm has been raging for at least 350 years, longer than telescopes have even existed. It's so massive that 3 Earths could fit inside it, and its winds reach speeds of up to 400 miles per hour. But why hasn't it dissipated? On Earth, hurricanes eventually lose strength when they hit land or cooler waters. Jupiter has neither. Its atmosphere is so thick and turbulent that storms can last indefinitely, or so we thought. Recent studies show the Great Red Spot is actually shrinking. In the late 1800s, it measured over 25,000 miles across. Today, it's less than half that size. Is it dying? Scientists aren't sure, but as it shrinks, it seems to be getting taller, like a spinning top narrowing as it spins faster. What could this mean for Jupiter's future? Now let's talk about those bands. You've seen them. Jupiter's iconic stripes, alternating in shades of white, yellow, brown, and red. These bands are actually powerful jet streams, moving in opposite directions. At the boundaries between them, storms form, twisting and turning in mesmerizing patterns. But here's where things get truly alien. Jupiter's poles. Unlike Earth, where weather is relatively calm at the poles, Jupiter's are chaotic. The Juno spacecraft revealed swirling cyclones, each thousands of miles wide, clustered together like petals on a flower. These cyclones are stable yet constantly shifting in intensity, a phenomenon we've never seen on any other planet. And then there are the auroras. Jupiter's magnetic field is 20,000 times stronger than Earth's, and it traps particles from the solar wind, funneling them toward the poles. The results are auroras hundreds of times more powerful than anything on Earth. But these aren't just pretty lights. They release X-rays, yes, X-rays, into space, creating a light show that's both beautiful and terrifying. Here's where it all comes together. Jupiter isn't just a planet, it's a laboratory. Its weather systems are so extreme, they challenge everything we thought we knew about atmospheres. The storms, the winds, the auroras. They're not just fascinating, they're a glimpse into the forces that shape the universe. And here's the kicker. Jupiter might hold clues to the weather on exoplanets, worlds orbiting other stars. By studying its alien weather, we could unlock the secrets of planets light years away, some of which might even harbor life. Jupiter's weather isn't just a spectacle, it's a story of extremes. A place where storms rage for centuries, winds scream at unimaginable speeds, and auroras light up the skies in ways we can barely comprehend. It's a world so different from ours, yet strangely connected to the forces that govern all planets, including Earth. So next time you look up at the night sky and spot that bright dot, remember, Jupiter is more than a gas giant. It's a reminder of just how wild and wonderful the universe can be.